Hello and welcome to the KIM-1 Corner episode 2. Now you may recall in the previous episode we made this device up so we can plug straight into a PC. Well, in this episode and future ones we'll be looking at this edge connector up here. This is the expansion connector and we've already had some boards plugged in there, but I thought I'd like to expand this, and here's what I've come up with so far. Now this is that connector. It's got various pins. We've got our supply up here and data bus and the address bus, interrupts, control and the clocks and the read-write signals. Pretty much all the signals we need for actually controlling more devices on the KIM-1. I thought maybe I'd just put memory on it to start with. But then I thought I might want to add other things. If I've got some software running on this extended memory, I might like to add in more peripherals, give it something to do. Here we've got a 44-way connector, and these edge connectors are not the cheapest going, and they're not the best quality anymore because they're not very popular anymore, so the manufacturing quality's gone down. So I thought I'll use different connectors. If we swap to the other camera, we've got these connectors here. Work out a lot cheaper. We've got this edge connector here. These are 0.1 of an inch spacing instead of the 0.156 connectors there. These ones are tighter so you can get more in. And we could use, these ones are quite small ones. I've ordered some longer ones. So we would have, here's the board to come up with. We have a connector plugged in like that. And then we'd have these will be mounted on the board that plugs in. Oops, dropped it. And that will just plug in there. We'd have multiple ones of these along here. And here's the other board I've got. This is the memory one I started designing. So these edge connectors would plug in here and fill them all up. And then just plug in there. And we'd have a board that stands up. And we could have up to 5 boards on here. I wonder if they're the right size, those ones. Well, I'll be. They're exactly the right size. They're better than the ones I ordered. Right, so that's how it will be. We'd have 5 of these, room for 5 boards. And on this end, I'll plug in, have one of these soldered on. And then that, we switch cameras again, and that plugs in just there. I plug in at that point there. And then we can have vertical boards standing there. As I said, that these connectors they're not very good. These parts in here keep snapping off. And I've got one of the old ones that damaged, yeah, you can see in here, the pointy stick. The camera will focus on it. This pin here is broken, so's this one, and this one are all breaking along here. And they end up sticking up in that focus. See, these pins are snapped off. These are not very good quality at all. I mean, it's only been plugged in a few times. And it's snapped all. How many gone there? 1, 2, 3, 4, 5, 6, 7, 8, 9. One up there. That's 10 out of the 44 snapped already. So I wasn't very impressed with those. Oh well, this board will have one on it. Unfortunately, it's all we've got to do, and it'll just that'll be plugged in and be stay in place. Well, this one, and then the other boards will plug into that, and these hopefully will be more robust. Now, because these are 0.1 of an inch pitch, there's actually 60 down here. So we've got 44 there, and that leaves me another 16 ways at the bottom that are spare. If we look at the actual circuit for this, I'll bring that up. Where are we? There we go. If we look at this one, this is the circuit diagram. Now these are the edge connectors. If we zoom in on one of them, oh, a bit too far. We can see these are all the pin connections that are at the top. So all these connections here are at the top here, exactly the same. Comes down to there. And then we've got these extra 16 pins here. One of the things I've decided to do on this is to do some of the decoding actually on this back plane, because otherwise I'm decoding the same addresses again and again. So over here we've got these 8 signals called 8K0, 8K1, 8K2. Well, basically I've taken the, let's see if we can find it on here. There we go. Let's zoom back out a bit. This is the KIM-1's memory map. It only does the bottom 8K of memory and then it keeps repeating. This would be, the whole lot of this would be just that one signal there. So I've taken the A15, A14, A13 and decoded them, and that gives me the full 64K chopped into 8K chunks. And they're the chip selects for those. So that's only have to do that the once and it's done on the back plane, and any boards that plugged in can pick off these signals. So with the KIM-1, that would just be 8K0. Then that can be subdivided into these 8 sections, which are 1K in size. So that's the 1K, the memory at the bottom. And these are the ROMs and the bit of RAM and I/O that sits here. And these ones are just blank spaces that are not being used at the moment. So there's 5 of these. And if we move over to this side, this is the edge connector that comes from the KIM-1 with all the addresses, etc. It just feeds onto this bus that feeds across to the others. And here we've got a 74138 that takes the A15, 14 and 13, demultiplexes them and gives us the 8K0, 1, 2, 3, 4. So each of these signals, that one is the bottom 8K, that's the next 8K, all the way up to the top 8K. Now what I've done here is I put another 74138 on, and I fed the 8K0 on there, so that's the bottom 8K. So that's this 8K we're looking at. And we've put on here A12, 11 and 10 and decoding them. Now these are the same ones as what the KIM actually decodes on board. So what we do here, oops, one button, should have done that one. So bottom 8K enables here, that divides it up. So these signals here are the bottom Ks. So I've called it 0 at the beginning to say it's the bottom one. Then K0, 1, 2, 3, 4, 5, 6 and 7. So that's these signals here. So when 0K0 is enabled, that is the bottom 1K of RAM. Now we're not actually going to be sending these signals to the KIM-1 because the KIM-1's got its own decoder, but what we need to do is we need to enable that decoder, and we'd like to have that enabled when either this one is on, this one is on, this one's on, or this one. So that's K0, 5, 6 or 7. If any of those are enabled, we need to enable the onboard decoder. So I've got here 0, 5, 6 and 7 feed into these AND gates, and they feed into this AND gate, and then come out to this KA signal, which we've mentioned before in other videos. And that is the enable signal to enable the onboard decoder of the KIM-1. So if we're looking at the bottom 1K or the top 3K of this zone, if any one of those is enabled, then we lose a signal, one of these signals. We lose one of these, which means we lose that signal. So if one of them is being used, we enable the onboard decoder of the KIM, and it will decode the onboard devices and run normally. And what this enables us to do is use these K1, 2, 3 and 4, which are, it's that one K1, 2, 3 and 4, which are not actually used. And we can fill them in if we wanted to. We could use those signals here to feed the chip select of a RAM chip if we wanted, and thus we could fill those spaces with RAM or whatever we wanted. Now these signals feed out via this jumper here to pin 19, because you may have noticed on my one, I've got this black wire coming from pin 19 that isn't used, and that runs down here and goes on to this KA signal, which is enabling the onboard decoder. Now the idea of that is I can just have a board plugged in here and not have to have this wire link down here to enable things. In the future, I might be able to get rid of this connector altogether, and we just be running off the top one here. Now I'll put the link there so that you can not feed the signal out, because you might want to do additional decoding, etc. with some other cards you design, so it gives you the option to disable that signal. If you're not using the pin 19 like I am, then you don't have to, you'd be using the wire coming across, but you don't have to connect that. Or if you are using it, you can just pull the pin on and off. If we go back to that, it gives you a bit of flexibility. Now over here we just got a few spare bits and capacitors that'll be on the board for decoupling. Now if we look at the actual board here, these are the ICs seen up here, the 008 for the AND gate and a couple of 138s for doing the decoding. I've also put some pins for the supply, so we can bring the supply in here and that will feed through out to these two pins and supply the KIM and everything. So there's that little jumper I was talking about just now, be there, and that's a wire you can run off to the bottom board if you don't want to solder a wire onto your KIM-1. So we need to put this together. It's just quite straightforward. We solder that up and plug it in. Okay, so we've got the KIM-1 going. Got the original connector on here. I plug that in to show that it's all working. Plug that in the power supply there. And voltage and reset. Well, you can't see that too well. Let's turn the lights off. Oh, there we go, that's better. So we can see it's all working okay. Yeah, let's look at one of the other addresses. There we go. It's all running and working fine. So we stop that. Now this is with the link on to enable the onboard address decoder. So we'll just take that off and we plug the new board in. Oh, it's a tight fit, these ones. I'm not surprised they break. Okay, and get the new power lead for this one. So in the bench power supply and plug that in around the right way. Don't want to blow things up. Right, and let's turn it on, and nothing. Now the power supply is showing 542 milliamps, and when we press the reset it goes down to 521 milliamps, which is very typical when it's running. So let's put the oscilloscope on this and let's see what's going on. And get the probe here. Right, let's see what pin it is. It's pin 7. That's going to tell us whether we've got any instructions being executed. Alright, let's bring the scope up. Alright, there we go. Get this oscilloscope going. Alright, there's pin 7 round the back. 1, 2, 3, 4, 5, 6, 7. And nope. No signal. Oh, yes there is. Yes there is. Oh, it's fiddly to get on the pins at the back here. Let's try that again. Alright, where are we? Pin 7. 1, 2, 3, 4, 5, 6, 7. Right, that pin. Press reset. Oh, come on. Here we go. So if we zoom in on that a bit. And there we go. That's showing that we've got instructions running. So it's doing something. It's actually running. Although obviously the display's not working. So it's not loading up the loader monitor for, well, sorry, loader monitor. That's an old term. It's not loading up the monitor ROM. So if we let's have a look at some of the address pins. So A1 is on pin 9. Right, there we go, on pin 9. Which should be A0. And, oh, there we go. A0 is switching on and off quite merrily. Let's try A1, which is on pin 10. There we go. That's half as often, but that's what we expect. So the processor's all running, but it's not actually running the monitor code that's in the O2 ROM. So can you tell what's wrong? Why isn't it running that monitor code? I know why it's not working, but can you see it? It's not that AK link that's missing that I just noticed. It's something else. So put it in the comments below and see if you can guess what it is, why it's not actually loading up the monitor and running. You'll find out in the next episode what's going on when I plug in the memory board and get it going. So don't forget to like and subscribe, and I hope to see you in the third episode.